Welcome to this MyEye.net product tutorial on building .NET data access layers with LANSA Open for .NET. LANSA Open for .NET provides middleware for safe and secure access to data and programs residing on the IBM I. Another feature of LANSA Open for .NET is its meta repository, which protects data integrity by enforcing data constraints on every attempted insert, update, or delete against our database. For today's exercise, the data access layer will be implemented as a .NET web service written in C# that uses LANSA Open for .NET's class library to access the meta repository. In addition, we've written a .NET rich client application and an ASP.NET web page to consume that web service and perform native record-level access to the database using the encrypted TCP/IP socket connection provided for by LANSA Open for .NET. With the meta repository, even our IBM I 5250 programs can take advantage of the business rules stored there, which means we can create and maintain all of our enterprise business rules in one spot and enforce them everywhere. The tutorial will make more sense if we view the finished applications before we see how they were built. Let's start with the browser application. On our ASP.NET webpage, the Retrieve All Employees button consumes the web service method that reads all the employees from the DB2 database on the IBM I. When we select My Employee Number, A0193, another method is invoked to retrieve the specific employee information about me. Watch what happens when I try to erase the first name and address line 1 and save the changes. The update method of the web service attempts to write the data to the database. Since the data did not satisfy the validation constraints defined in the meta repository, the update was aborted and LANSA passes back 2 error messages. We'll see where those messages come from in a few minutes. Let's change my name and update my address and click the Save button. The record is updated since all the validation rules were met. Here we are in the .NET Rich Client application. Again, clicking on the Retrieve All Employees button consumes the same web service as the browser application to select all the employees. Clicking on My Employee ID calls the method to read My Employee Record. Now, if we blank out the first name and the address line 1 again, this application displays the same error messages as the browser application because it invoked the same update method. Let's put valid data into the form and click the Save button. Just like with the browser application, calling the update method with valid data will allow the record to be updated back in our DB2 database. Lastly, here is our 5250 application. Once we've entered my employee number, we can see my information. Pressing F21 puts us into change mode. Now if we blank out my first name and the address line 1, the results will be the same repository rule enforcement as the .NET applications. These rules are defined once in the repository and enforced from all 3 interfaces. Next, building the data access layer. First, we'll review the web service source code to see how the LANSA Open for .NET class library is referenced. Then we'll look over the source code that consumes the web service. And last, we'll change a business rule in the repository, rerun our applications without recompiling or redeploying the .NET web service to witness the business rule change. First up, the web service source code. We've started Visual Studio and we'll open up our project for the web service. Here is the source code for the web service called Person Manager, which contains 3 web methods. The first one is called getList, which returns a list of employees. The second one is called getItemsByEmployee for which we pass in the employee number and it returns back employee details. And the third one is the update method, which updates the employee record back on the server. So if we look at the source code for the getList method, this is where we set up the connection to the server. The connection comes from a class called Connection Manager, and that code is located in the LANSA class library. Here is the Connection Manager. It just defines the parameters on how to connect to the server and retrieve information. Back to our Person Manager. After we have acquired the connection to the server, we specify which table or tables we want to use. We also specify the fields we want to get back from the server for a table. And LANSA Open for .NET then returns a data table. Once we have the data table, we can transform the data table into a collection of person objects by using the Data Transform class. The data transform class is located in the LANSA class library, and it takes care of encapsulating the transformation of the data table back into the collection of person objects. We'll skip over get item by employee and go directly to update, because that's where the meta repository interaction comes into play. The update method receives a list of person objects that you want to update. It then goes through each person object inside the person list that needs to be updated on the server. Next, we call the update method for the personnel table, which actually does the update on the server, and then checks to see if the status is okay. If the status is not okay, we retrieve all the error messages so that we can display them to the end user. Notice there is no business rule logic here in the source code for things like first name, address, etc. All that is stored on the server in the meta repository. The last item we'll look at is the web.config, which externalizes the parameters used by the connection manager. It contains items like server address, port, which language to run in, login details, etc. Externalizing the parameters makes it easier to maintain the server information. Next, we'll inspect the source code to invoke the data service layer from the rich client application. We'll make it quick since consuming this web service from ASP.NET or WinForms is no different than invoking any other web service. Let's explore the source code for clicking on the Save button, which invokes the update method of the web service. The employee object is set up here, which is of type person. We set it to the current employee, retrieve all the information from the form, set the properties of the object, and call the update method. Once done, the update method returns back result items, which are error messages from the meta repository. No results means the update was successful. When there are results, we loop through the result item collection so we can gather all the error messages to display to the end user. Up next, we'll use the LANSA meta repository to make a business rule change, and without having to recompile or redeploy any of our .NET projects, we'll see our applications take on the new rule immediately. This is the interface that the LANSA Repository Administrator, or LRA, would use to work with the meta repository. Since we need to change a business rule on the table called PSL-MST, let's double-click on it to view its definition. Once the definition appears, we select the tab called Rules and Triggers. This is where we'll find all the business rules for this particular table. What we want to do is change the rule for the first name field, which is called given name in the table. Upon expanding the given name field, we see the existing rules actually defined at the field level. With the repository, we can apply business rules at the field level or the table level. Rules assigned at the field level are enforced for every table containing that field. Rules assigned for fields at the table level are only enforced for that specific table. The field level option provides LRAs with an extra level of enforcement. We've opened up the given name's field definition so we can change its business rule. Again, clicking on the Rules and Triggers tab allows us to view its business rules. Currently, the rule makes sure that the first name is not blank. We want to change it so that the first name cannot be David. Next, we tell the repository that when this condition is true, we have an error condition. Otherwise, ignore and continue on to the next rule. Also, we need to change the error message that gets returned to both the .NET and RPG programs. We'll change it to read, first name cannot be David. Next, we save our changes, close the field definition, and recompile the data access layer that resides on the IBM I server. This is not compiling any of our .NET or RPG programs. It only compiles the LANSA repository object. Here we are back at our .NET browser application. Nothing has been changed to the application or the web service. As you can see, it's still displaying the old values because the screen has not been refreshed since we changed the data on the rich client application. So let's click the Retrieve button and refresh the grid. Clicking on the Save button as is will come back with an error since we're trying to enter David as the value for the first name. That rule change came from the repository without having to recompile any part of our .NET applications. Now we're back working with our .NET Rich Client application. Again, if we try to save this record as is, just like with the web page, the record will not be written and will receive the same error messages as that ASP.NET program. In summary, what did we accomplish today? Well, we built a web service that used LANSA Open for .NET for native data access back to the IBM I. We wired up rich client and browser-based .NET applications to consume that web service. And most important, we entered business rules into the meta repository that was enforced by all of our applications. We also witnessed that changing a rule in a repository can be put into production without having to recompile or redeploy any part of our .NET applications or projects. And again, all three environments were able to share the business logic: web, Windows, and 5250.